So we're here with Uri Cohen, Head of Product Management at GigaSpaces, and we wanted to talk a little bit about some of the APIs that GigaSpaces provides to access really data in a data grid. What can you tell me about the main APIs people use?
Okay, so basic API is we call it the Pojo API, or we model it after the GigaSpaces API. I would say this is the most popular and powerful API that we have. Then we have the Map API, which is simply a JCache integration. It's very adequate to caching scenarios or very simple scenarios. And more recently, we've added a couple of other APIs. Memcache would be one of them, which is very good for scenarios where you want to integrate with, I'd say, other platforms. If you have a PHP web application or a C++ client or a Python client that you want to access the grid with, this would be a very good choice to go with. The most interesting maybe is the JPA API. So we actually expose the data grid as a JPA resource, and instead of really, when you're doing the JPA calls, instead of actually tunneling them through a relational database, you actually work on the data grid, thus getting all the performance and scalability boost of the data grid, but while still working with an API that you're very familiar with. And the last one that we're talking about is the document or schemaless API. And that's mainly targeted at highly evolving applications where you'd want the schema or the data definition to be very flexible and constantly make changes in it, including indexing the data, adding new properties, and in general, evolving your data types as you move forward.
So let's look at the JPA API. For one thing, what drove us to use JPA instead of JDO? Because like Google, the Google App Engine uses JDO as its backend. What made us look at JPA instead?
So that's a good question. Basically, what we've seen from the market is that JDO is it's not a very popular specification. It's kind of left in the shadows, if you will. And we see JPA as kind of the modern incarnation of it. Most people, most enterprise developers that we're in touch with actually use either Hibernate or JPA or a combination thereof. And we're seeing JPA, picking up more and more traction as Java EE6 is moving forward. So I would say popularity would be the simplest answer here.
Well, that makes sense. How does JPA affect the grid access? Because like one of the powerful things that a data grid gives you is the ability to span a request across multiple nodes. Wouldn't JPA have a performance impact if we do that sort of reduction?
So the secret behind that is that while we do provide the JPA capabilities, what we do is we don't kind of remove the power of the grid. So you can still determine things like data partitioning and how you do relationships. So by default, relationships are not spanning multiple partitions or multiple nodes in the cluster. So they do work very fast. And then again, on top of that, what we're able to do is always fall back to the Pojo API. So if you do need to do something more sophisticated, like execute a certain piece of code across the grid or implement kind of a map reduce operation, you can still do that, because at the end of the day, it's just Pojo's saved into the data grid, which you can work on.
So what you're saying then is a typical application won't rely on a single API, but will use the correct API for the data that needs to come across.
Yeah, exactly. So that's kind of the key concept we're trying to convey here. There are a lot of distributed data stores out there, relational databases, data access APIs, and each of them was tailored to a specific use case. And when you asked me the second question, I answered, but I kind of described what each of these APIs is good for. But in many cases, what you actually have is all of those use cases for each of the APIs within the same application. So, for example, you have a front-end PHP client, which actually wants to do some data caching on the grid. And then at the back end, you have some smart piece of code running which needs a Java piece of code which needs a sophisticated POJO model or a JPA model. Then on another piece of application, you would even have kind of a reporting tool that needs JDBC. So all of these use cases work on the same data, but each of them would need a different API to work with optimally. So we enable you to do all that flexibility on the same data set.
Does that include the document API? Would we be able to access something with the JPA and the document API at the same time?
Yeah, definitely. That's also a good point. So think of this scenario. Think of a web application that does use JPA and writes stuff into data grid. And then think of another client which wants to do some data manipulation or reporting on that specific piece of data, but doesn't necessarily have the class definitions associated with that web application that uses JPA. So much in the same way you could access a database using the raw native API like a JDBC API, you can actually use our document API, retrieve those objects while still maintaining, of course, their kind of object-oriented structure or nesting, and not flattening the model like a database does, and do some stuff with it, some meaningful stuff with it.
So that means that you get transactions persisted across not only the data grid itself, but you get the APIs that have transaction capabilities. You can use, assuming your schema doesn't change too much, because that's really the key, right? The schema evolution makes the decision as to which one's appropriate.
Yeah. That's one of the key decisions. So, like I said, if you are expecting a highly evolving schema, the document would be the way to go. If not, JPA would be the way to go, and there's even a nicer facet to that, is that the capability you can even combine both. You can actually have kind of the constant part of your schema modeled as a POJO, and then a subset of that POJO would be actually a dynamic data type, like a map, in which you add and remove properties on a as a needed basis, and evolve that part of your POJO over time. And of course, it's not just a dumb map that is serialized into the data grid. It's actually analyzed and understood by the data grid, so you can actually do some smart querying on that, like get me all the POJOs whose map contains a certain key, a certain value for a certain key, and in general, extract the data in a much easier fashion than if it would be just a blob or a serialized byte array.
And we still have the capability to asynchronously persist this safely, so we don't ever lose data, and we can move it to a relational database for warehousing purposes or whatever else, right?
Yeah, definitely. So we have what we call the external data source interface. In previous versions, what we had is a default implementation for relational databases that was based on Hibernate. So we took the POJO, mapped it into the database via Hibernate, and persisted stuff. Now with these types of models, Hibernate might not be the ideal tool, because in some cases you don't even have the POJO, right? You just have a map of maps, if you will, a document. So we still provide those capabilities. In some cases, it is the user's responsibility to actually take that document and decide how to persist it into the relational data store, or even a document database or a flat file, or whatever it is they choose to persist with.
Thank you, Uri. Appreciate it.